All right, let's go ahead and start with section 1.5. This one involves addition and subtraction of real numbers. And essentially, this is just a lesson on adding and subtracting positive and negative numbers. And it starts off with the first part of the lesson into just kind of using a number line, which I think gives you a little bit of number sense as to how positive and negatives work with each other. Like for instance, for number one, I wouldn't expect you need a number line to solve number one, but 4 plus 3 is 7. We know that to be true. Number two, -2 plus -9. Well, that's kind of worth using a number line there. And so -2, if we start at 0, well, we go left 2, because anything negative on the number line means we're going into the negative territory, meaning left. We're going the opposite way of the positive numbers. And then we're going to go -9. So -9 would be 1, 2, 3, 4, 5, 6. And then I run out of spaces on here, so I'm going to add some more. -9, -10, and -11. So I would expect -9 to go that far. It was essential that we extended the number line to -11, because otherwise we wouldn't be able to fit -9 on there. But yeah, -2 plus -9 is -11. And you may kind of remember in the back of your head that, 2 negatives make a positive. However, when it comes to adding negatives, it's not true, right? You have, if you think about this in real life terms, the temperature went down 2 degrees and then it went down 9 degrees. Well, it didn't go up 11, it went down 11. Or think about money. You spent $2 and you spent $9. You're down $11 in your wallet or in your account. You're not up 11. You didn't magically make money by spending money. For number 3, we've got -7 plus 8, which is a good example to show with a number line. Kind of just show you kind of how they, how they kind of cancel each other out. Not completely, but you can kind of see what's going on here. So we've got -7. So I'm going to go to -7 on the number line. There's -7. And then I'm going to go up 8. So all the way to 1 would be up 8. And that's where you leave off. If you're using a number line to work out these problems, where you leave off is your sum or your difference. In this case, it's a sum, even though we are looking at this more like a difference. But that's the answer. The answer is +1. And then -5 plus 3. -5 plus 3, we can kind of do the same thing here. All right, I'm going to go left 5 on the number line. That represents -5. And then we're going to go up 3. So that's going to leave us at 2. All right, meaning that's the answer. Why did I say 2? It's -2. That's what I meant to say. All right, so the rules for adding real numbers, integers, or just sign numbers in general, is that when they have the same sign, whether you're doing like -9 plus -5, or you're doing 8 plus 12, those both those problems have the same sign. So when that is true, when that is the case, you're going to add those numbers up. Another way to put that is that we're adding up the absolute values. Okay, we're adding the absolute values, and then we keep the sign. So if we're adding negatives, we're going to keep it to negative. If we're adding positives, as it always has been, we're going to keep it positive. So that's what we're going to do here. And so all these examples right here involve adding numbers with the same sign. So we have -3 plus -8. That is -11, right? We just keep the sign. All right, -52 plus -79. We're going to find the sum there. We're going to find the sum. So we're going to do, basically, we're going to add 52, the absolute value, of negative 52 is 52. The absolute value of negative 79 is 79. And we're going to add those values up. We're going to add them up. And you should get, what is it, 131? I think that's what it is. And it's negative 131, I might add. Okay, number 7. All right, we have fractions, and we have fractions with uncommon denominators. So we better find a common denominator before we do any adding or subtracting. So we're going to find the LCD, which is 4. We're going to find 4, and then negative 1/2 is negative 2/4. And then negative 3/4 is right here. And here's another thing too. When you're dealing with negative fractions, my advice to you would be to always bring the negative up to the numerator. You know, in the original problem, you'll see that the negative is right in line with that fraction bar. It's called a vinculum. If you want to know a little bit of weird fact about fractions, it's called a vinculum, but that does, never mind that. But I find it more useful to tell my students to bring it up to the numerator. I would say bringing it down to the denominator is probably not a good bet. But yeah, you have negative 2/4 plus negative 3. So now you're looking at them and know what to do with those values. So negative 2 and negative 3 makes negative 5. And then just as it always is, we're not going to add or subtract the denominators when adding or subtracting fractions. Okay, now this is just a decimal problem, and they both have the same sign, so it's no mystery here that we're going to just add those up. We're going to add up, so 0.2 and 0.56 is going to be negative 0.76 or negative 76 hundredths. So there you say it. All right, now the rules for adding real numbers with different signs is going to be like this. If we have like I don't know, something, I'm going to do something really simple, but like negative 8 plus 3. Okay, negative 8 plus 3, or 12 minus 2. 12 minus 2. Now, both those problems have different signs if you think about it, if you really think about it. Now, let's kind of focus on the negative 8 plus 3 here. Negative 8 plus 3, they have different signs. Obviously, this one's negative, the 8 is negative, and the positive is the 3. So when that happens, when you have negative 8 plus 3, and this is really important that you guys understand this fully, is that when you add or subtract different signs, you find the difference, okay? So that's what you want to do. Okay, so it's kind of writing down a bit there. So I wrote down that you want to find the difference of the values, meaning you're going to subtract, okay? And then the part that you would really want to think about here is you want to keep the sign, you know, the sign that determines what the answer is going to be, what the difference is going to be determined by the number with the larger absolute value. So in this case, negative 8 has a larger absolute value than positive 3, right? Negative 8 is a small number, but if we look at it just absolute value wise, it's a larger number than 3 because it's further away from 0. Therefore, that makes that answer negative 5. That makes that negative 5. All right, and then just for fun here, we don't have to work this out. I mean, you know it's 10, but 12 is positive, and it's good to know that 2 is negative. It's good to know that that 2 is negative, because subtraction, I think maybe you know this already, maybe you don't, but subtraction, by just proxy, by where it's located, makes the number that's in front of it negative, okay? So as you can see right here, we have minus 2. That really means negative 2. You know, that could be written, that could also be written as 12 plus negative 2, all right? Now, I know I just made that more complicated. 12 minus 2 is a much easier problem. That's when you're used to working out, but it is good to know where the negatives are located when you're dealing with a problem like this. Okay. All right. So for number 9, all right, we have different signs. So we're going to find the difference. And it looks like the number 43 has a larger absolute value, negative 43. Negative meaning the answer is going to be, it's going to come out negative, not positive. Sometimes I try to tell people it's like a battle going on. You have negatives versus positives, and who's going to win? Who's going to win that war? Who's going to win that battle? And in this case, when you have more negatives, they're going to win. They're going to win out. But yeah, you got negative 43, negative 27, which is going to be, we're just going to have to find the difference, negative 16. Okay, 4/9 plus negative 5/6 right there. We don't have an LCD, so let's go ahead and do that first. Our LCD of 9 and 6 is 18. 18 is a multiple of 9, and 18 is a multiple of 6. 9 times 2 is 18, right? 9 times 2 is 18, so we're going to do 4 times 2. And 6 times 3 is 18, so we're going to do 5 times 3. So that's what those numbers are going to change into. So we're going to make this one 8. And notice how this one has a negative right there. So I'm going to pop that up to the numerator and make that negative 15. Okay. So sometimes, like when another point about where the negative is sometimes it gets kind of lost in the mix in there. And if you bring it up to the numerator, it's less likely to be kind of overlooked, which is, I think, a good thing. All right. So now you know what to do. We have 8 and negative 15. We better subtract those. And it looks like the negatives went out on this one. There's more negatives. So that's going to be it. That's going to be negative 7/18. Negative 7/18. And that cannot be reduced. All right, number 11. Number 11, you'll notice here, this is our first one where the positive has a larger absolute value. Therefore, this is going to come out to be positive when we're all done with it. So we just have to subtract these. That's all you're doing. 5.1, 7.8 minus 5.1, which is 2.7. Positive 2.7. Sometimes people put positive signs there when they know it's positive, but you don't have to put anything down if it's positive. You know it's positive, even if you don't put anything down. However, if it's negative, you must put a negative sign. And then for number 12, you got negative 14 plus 14. Those are additive inverse of each other. Additive inverse, they essentially cancel each other out, right? So those equal 0. Now, when it comes to subtracting real numbers, now that's kind of an entirely different thing, a little bit, but there's one way to make it easier, I believe, on yourself, and that is to change it to, I don't know if I'm making this easier on you, but sometimes people find this annoying, but I do find this useful, which is, I think if you change it to addition, if you change it to an addition problem, you're going to be good. So what I mean by that, and let's just go right down to the problems right here for number 13. For number 13, I want you guys to recognize that 7 is positive and 18 is negative. And that's because of that proxy rule, because where 18 is located right next to subtraction. And because subtraction is right next to that number, it makes it, just by default, makes it negative. So if we want another way to write this, which I think sometimes helps people think these through a little better, is if you just write it as 7 plus negative 18. 7 plus negative 18, which is maybe, if you think of it that way, you're less likely to make a mistake about what to do, whether you're adding or subtracting. And in this case, we are subtracting. And we can tell that the negative has a higher absolute value. Therefore, it's going to be a negative answer. And we know it's going to be negative 11. Okay. And that's like a good thing to kind of follow. We have negative 5 minus 20. Negative 5 minus 20. So instead of writing negative 5 minus 20, I'm going to write negative 5 plus negative 20. Which now we can kind of see, like I think with this particular problem, you can see exactly that they both have the same sign. Therefore, we better add them. We better find the sum. So it's negative 25. Negative 25 right there. All right. Now 15 is such basic, normal rote subtraction problem, but let's go ahead and let's think of it like a negative number problem. We got 32 plus negative 10. I mean, we already knew it was 22, but what the heck? It's 22. And then right here is something I have not talked about yet, which is when you have a double negative. All right, now the double negative rule is that when negatives are right next to each other, they make a positive. So I'm writing down like a kind of a random number there. But you've got on this one, you've got what do we got? The opposite of a negative. And I want you to think about that phrase for just a moment. The opposite of a negative. And the opposite of a negative, well, the opposite means minus, right? The opposite, like we're doing the opposite of something, we're negating it. We're putting a negative sign in front of it. So the opposite of a negative, and then the negative here in this case is the 4. So the opposite of a negative, now just think about it, just play opposite game here. The opposite of a negative is a positive. So that comes out to be positive 4. Just like the opposite of a bad habit, and sometimes that's the analogy I kind of use when explaining why 2 negatives make a positive. But if you think about that, if the opposite of a bad habit is to then in turn have a good habit, you know? So if you have, let's say, you take away the bad habit of not exercising, you know, not being active. Well, then if you're taking away that bad habit of not being active, well, you are now being active. You are productively working out. So that's a positive, right? If your bad habit is not flossing, well, you are now flossing, right? You're flossing daily, just like your dentist tells you to, right? Yeah, nobody does, but you should. You should. All right. So back to number 16. Back to number 16. Those 2 negatives make a positive. So you got 26 plus 31. I want you to make note that that 31, it was negative before, but now it is completely, entirely positive. It's 26 plus 31. It's not 26 plus negative 31. It's just 26 plus 31, which is, I think, 1,000. No, it's not. It's 57. Positive 57. There you go. All right, next page. We've got some problems here. We've got the lowest temperature ever recorded in Chicago was negative 27 Fahrenheit. The highest temperature in Chicago was 105. I remember that day. What is the difference between those 2 temperatures? And so the question is asking in this particular problem, what is the difference? What is the difference? Difference means subtraction. So if we set this up as a number problem, we've got negative 27 minus, because it says the difference, 105. So you have that, or you can write it like this. Actually, I'm changing my mind. I want to write it like this. I want to do 105 minus negative 27. Okay, so negative 105 minus negative 27 really means 105 plus 27, because we're looking at essentially how far apart are those 2 numbers from each other. How far is 27 degrees below 0 from 105 degrees above 0? You know, so it's total, cumulatively, it's 133 degrees. So that's all you have to do. It's 133. All right, so we got some examples here to run through. For number 18, I think for these, we just kind of want to follow the exercise of following order of operations and just kind of how to deal with these numbers. So for number 18, we're going to do the parentheses first. So 4 minus 12 is the same thing as 4 plus negative 12, right? 4 plus negative 12. which is -8, -8. And then 5 minus 2, you don't have to overthink that. That's the same thing as, 5 minus 2. So just put 3. So -8 plus 3 is -5. You can also think of that as 5 plus -2. All right, going on to number 19. Number 19, we're going to do parentheses first. Notice there's a subtraction sign or a minus sign hanging outside the parentheses, and it may or may not affect the outcome of what happens in the parentheses there in the grouping symbol. And we're going to pay attention to that. So we got 21 minus, and then 8 minus 3 is 5. Oh, what did I do minus 3 for? Sorry. I'm going to do 8 plus 3, which is 11. So 21 minus, I think I had the subtraction in my head. We have -21 minus 11. Now I'm going to write that as an addition problem. -21 plus -11. And then it's easier to tell at this point that you're going to add those up. -21 and -11 make -32. All right, in this example right here, we've got absolute value signs, okay? Absolute value. So we want to treat those differently. I mean, we are going to treat those like parentheses in a way, but because we want to do those parts first, the way it's grouped. But we still want to treat them like absolute values as well. So let's go ahead and do this part first. So -11 plus 46, so the absolute value of that, well, -11 plus 46 is 35. 35. So I'm going to keep the absolute value here. Absolute value of 35 minus 2, and we might as well just do this part too. 6 minus 9. So the absolute value of 6 minus 9, well, that's really the same as 6 plus -9. 6 plus -9 is -3. All right, so what you want to note here is that we've got a 2 with no symbol between that and the absolute value sign that's next to it, which is inferring that we should multiply those. We're going to do -2 times the absolute value of -3. All right, so let's take care of those absolute values first. Let's do that first. So the absolute value of 35 is 35. Remember, absolute value is always positive. It's always positive. All right, -2. And then I'm going to write down a time symbol here because I just want to remind myself that we need to multiply. And the absolute value of -3 is 3, because that's how far away -3 is from 0. It is 3 units away. All right, so we're going to follow order of operations here. We're going to do multiplication. Do multiplication first. I'm going to leave 35 in the front. So 2 times 3 is 6. So 35 minus 6. So 35 minus 6, that's easy. That is going to be, that was about right, 19. That is 29. All right, number 21. In that example right there, we've got an example where we have 2 negatives. Now that's the opposite of a negative. So the opposite of a negative is a positive. So I'm going to write this, I'm going to rewrite it as 1 2/10 plus 3 4/10. 1.2 plus 3.4. And this is pretty simple addition. So it's going to be 4.6. Right. Moving ahead to number 22, we're going to do parentheses first. Now -3 minus 2 is the same thing as -3 plus -2. -3 plus -2. Now -3 plus -2 is -5. And notice there was a subtraction sign already there. Okay, so that was not affected. But what we got in the grouping part, in this part right here, was a negative. So it's important in this part to pay attention to the fact that there's 2 negatives right next to each other. The opposite of a negative is a positive. So the opposite of an opposite is a negative. The opposite of an opposite is positive. That's what it is. So you got 8 plus 5, which makes 13. All right, then we got a fraction problem here. Get a fraction, so we just got to find LCD. And then, like I said before, I'm going to put those negatives up into the numerator. If we can, I think that's a good spot to have them. And the LCD in this case is 4. So we're going to rewrite those fractions. Well, only one of the fractions doesn't have a denominator 4. I know, so I wrote, instead of writing -1/4, I'm writing plus, because I'm going to put the negative in the numerator. And, well, 2 times 2 is 4, so we're going to do 1 times 2. Or -1 times 2, which is -2. -2, we're going to have -1 here, and then this is unchanged. Okay, and at this point, let's just go left to right. So -2 and -1 makes -3. So you should have -3/4 plus 3/4. Well, that right there is a perfect textbook example of opposites or additive inverse, which makes 0. Those cancel each other out. I think I have one more page on this. Yeah, for 1.5. Okay, so for 1.5, English expressions to mathematical expressions. I just want you to kind of be on the lookout for the word then or more than. Let's talk about that for a second. All right, when you see more than, or if you see less than, let's go ahead and talk about these kind of concurrently. So when you see the phrase more than or less than, our first instinct is to put like plus or minus, which is not a bad guess, but it's the important part is where you put the plus or the minus. Okay, and when it says more than, you want to put it after. You want to put the operation before the number. So. And the same thing goes for subtraction. Okay, so that first example right here, we've got 18 more than 6. 18 more than 6. So you've got that more than. All right, so some of my students, they call that the word then a switcheroo number or whatever. And it's okay if you have your own way of thinking of it, but for the switcheroo, that just means like things kind of get switched or if they swap positions. So that's what happens here. So you got 6 plus 18. However, this is addition, so order doesn't really matter. So you can write it as 6 plus 18 or 18 plus 6, 6 plus 18. It's not going to affect the outcome of that sum. It's still going to be 24 either way. With subtraction, it is more important that you pay attention to the order, like in number 25. So it says 5 less than 81. So we really want to write this as 81 minus 5. So we want to put the subtraction before the number 5, not after. We don't want to do 5 minus 81. It's 81 minus 5. 81 minus 5, which is, what is that, 76? That's it. All right, -14 decreased by 12. Now, nothing really tricky about this. Decreased is just a word telling you to subtract or negate. So -14 decreased minus 12. All right, -14 decreased by 12. So if you think of that as addition, -14 plus -12. Okay, so that makes -26. Just want to see if sometimes I zoom in, I don't know if I'm missing anything here or skipping over something. For number 27, we've got the sum of -1 and 28. Well, sum is a word that's telling you to add. So we're going to do -1 plus 28. All right. Well, when you really think about this, no adding is taking place. It's actually a difference problem because they have different signs. This is a positive, right? And oops, why am I, maybe I got COVID brain. This is a negative, and this is a positive right there. You got a negative and you got the positive. And so when that occurs, you're going to really find the difference. And remember, the rule is keep the sign of the number with the higher absolute value. And the higher absolute value is positive. It's 28. So that's going to be the answer. It's going to be 27. All right, moving on to number 28, we've got 21 more than the sum of -8 and -7. Now, this doesn't always work out that way, but and when you see the word and, it's a basic conjunction word, talking about language arts type stuff here, but it's basic conjunction word. But I'll tell you what, it's a good giveaway for parentheses or some type of grouping. We're grouping something up. All right, so we've got 21 more than, we've got the more than symbol. So that means we want to put that after it. So we're going to put -8 and 7, and -7, I should say, in parentheses. And then I'm going to put plus 21 at the end of that, because it says 21 more than that, 21 more than the sum of -8 and -7. So -8 and -7, that makes -15. Drop down the plus 21. And so now you can tell it's a subtraction problem because they have different signs, right? We have a negative and we have a positive. And the positive has a higher absolute value, therefore it's going to be a positive answer, positive 6. All right, 3 increase. 3 is telling you that it's positive, or not 3, but the word increase is telling you that it's going to be addition or a positive value. So 3 increased by 32 means 3 plus 32, which is 5,000. No, it's 35. That'd be really bad math right there. That's 35. Okay, so that does it for this lesson. Okay, so that does it for lesson 1.5. Just to let you guys know, I'll put this on Blackboard as well, but college notified me and I can return back to in-person classes on Tuesday. So I don't want to return any sooner than I need to, just for your welfare. And I think I'm getting better. I feel like, again, I just feel like I had a little cold and was a little tired, but doing all right. So hopefully I don't have too many more lessons here from my lovely basement where I've been holed up for the week, where my family's been serving me food and chips and throwing stuff down the stairs for me. So, all right, but I'll stop there. Everyone have a great day or night, whatever it is for you, and I'll see you again. See you at the next lesson.